Guys, why are they not joining on time? சந்துரு என்னாச்சுங்க? யாருமே காணோம் உங்க கிளாஸ்ல.
சார் தெரியல சார், லேட்டாக வருவாங்க சார்.
லேட்டா வரக்கூடாதுல்ல. டி செக்ஷன் ரொம்ப கம்மியா இருக்கே.
Yes, sir. It's almost time. It's 2:10. So I'm starting I'm going to revise the last class. So the last class I have talked about the motor characteristics. So normally I have said it is classified into the DC and AC. It depends upon the supply. Again, DC is further classified into separately and self-excited DC motor, and self further is classified into shunt motor and series motor, and another one is compound motor. Sir, echoing, sir.
No, it's not echoing.
Okay, sir. So the another one is compound motor. The compound motor is further classified into long shunt and short shunt and cumulative and differential motor, DC motor. So in I have last class I have talked about the shunt motor. If field winding and armature winding is connected in parallel, I used to say is a shunt motor. The same way series motor, if both windings connected in series, it is called series motor. The same way for compound motor, the combination of both shunt and series winding is connected together. So for long shunt, if I am drawing, you can understand what is meant by long shunt and short shunt. In some textbooks, they have given field or shunt. So sometimes they used to say is a ISH, and then this is my IA, because here only I used to say is a armature 1 and armature 2. And then this is F1, and this is my IL. This is my long shunt compound motor. If the both combination of field shunt and series winding connected together. If my field winding is connected purely parallel to the series as well as armature, it is called long shunt. If I'm connected only with respect to for short shunt, I'm going to draw here, then only you can easily understand. So if I connected the field windings only parallel to the armature winding, that is, this is called short shunt. If I connected respect to the both armature as well as series winding, it is long shunt motor. Yes? Have you all understood? While seeing the diagram itself, we can understand what is meant by long shunt and short shunt. The field winding is purely parallel to the both series as well as armature winding. It is called long shunt. If it's only connected with respect to armature, so this is called short shunt. Is it clear? Is it clear or not? All of you?
Please respond.
Somebody unmute and say, have you all understood what is meant by long shunt and short shunt? Yes.
Yes, ma'am.
So now I'm going to write the voltage equation and current equation for the long shunt. Here, the current is dividing here. So I have to take ISH as well as ISC also. Here my ISC is followed the IA. So my IA and then ISC will be equal. So if connected in series, the current will be same. And then the same way, the voltage will be same. What is that? If is connected in parallel, the voltage will be same, and then if it is connected in series, so the ISC and IA current will be equal. So from this I can write IL is equal to ISC plus ISH, because we know that ISC is equal to IA. So I can write it as IL equal to ISC plus ISH. This is my load current. And then we know that I can get ISH by V by RSH by the Ohm's law. Then finally, I'm going to write the voltage equation. It is nothing but EB plus IA RA plus IA into RSE. This is the voltage equation. Why I didn't write the voltage equation of the field? Say, why I didn't write the voltage equation of this shunt field? Anybody unmute and say, I have took only the armature as well as series winding. Why I didn't take the field winding voltage equation? Why? Why? I'm talking with you only. I'm going a bit slower only today. Have you all got my point, what I'm asking? Why I didn't write the shunt field voltage equation? Why? If you know or not.
113. Can you answer the question?
I'm parallel.
Yes, it is connected in parallel. The voltage will be same. I can write this part alone. So it will be equal because the voltage between a field winding which is equal to the series as well as armature winding. So I can write it as V is equal to EB plus IA RA plus IA RSC. Very good. Who said the answer?
121, ma'am.
Oh, super, ma'am. The same way, is it clear? The long shunt motor voltage equation as well as the load current? Yes, I hope so. And then I'm moving to the short shunt motor. Here, again, the current will be differing. So I have write it as, here my IL equal to ISC because it is connected in series. So the same current will flow to the IL as well as ISC. So it is IL equal to ISC, and then same way my IL equal to IA plus ISH. Okay? Am I right? Because it is connected in series. So series current will be same. So IL equal to ISC. So I can write it as my IL equal to IA plus ISH. Here again I can write it as ISC is equal to IA plus ISH. Both are same because we know that IL equal to ISC because it is connected in series. If it is connected in series, my current will be same. And then next I'm going to write the voltage equation for the short shunt. V is equal to EB plus IL into RSC plus IA into RA. Yes? Is it clear? You can write it as ISC also because ISC is equal to IL. So they have write it as IL into RSC. Both are same. This is the voltage equation of my short shunt compound motor. Again, it is connected in parallel, so no need to take my field current value. I can take my armature voltage equation. So it is IA into RA. Is it clear? Is it clear or not? Is it clear?
Please respond in chat box or else you can unmute and answer the questions.
Ma'am.
What?
Don't you repeat?
I have to repeat once again for short shunt.
Yes, ma'am.
Okay. So the same way, I'm going to write the load current as well as voltage equation of the short shunt. Here it is IL and IS is connected in series, so the current will be same. So I can write it as IL equal to ISC. For the same, for the short shunt motor, I can write it as ISC equal to IA because it is connected in series. The same way here, my IL load current is followed to the ISC. So the both currents are equal. If it is connected in series, the current will be same. So IL equal to ISC. I can write it as. And then I need IL value. Load current only I have to know. I have to took. So I have to change it as IL is equal to, it is divided into parallel. So IA plus ISH. This is my load current. So IL equal to IA plus ISH. I can write it as IL instead of ISC also. So ISC is equal to IA plus ISH. And then I can write the voltage equation of the short shunt motor. So I have to took V is equal to, normal formula is equal to V is equal to EB plus IA RA. The last class I have told the voltage equation of the DC motor. The same I can use this also. So V is equal to back EMF plus, here it is connected in parallel. So IA into RA plus ISC into RSC plus IA into RA because here it is connected in parallel. So in parallel, the voltage will be same. While writing a voltage equation, I can consider any part, either armature or field. Anything you can took. So I can took the armature value. So V is equal to EB plus ISC into RSC and then IA RA. This is my voltage equation. V is nothing but, it is nothing but voltage. V is equal to I into R. The same Ohm's law, and I have write it in terms of the series and then field, nothing else. If it is following towards the series winding, I can write it as ISC and then RSC. Normally, the voltage equation will be V is equal to I into R. So basic Ohm law. From this, I can write it as, if it is series, I can write it as ISC into RSC. If it is flowing towards the armature, I can write it as IA into RA, nothing else. Again, I can replace ISC with respect to IL because my IL equal to ISC. So V is equal to EB plus IL RSC plus IA into RA. This is the voltage equation of the short shunt motor. Yes? Is it clear?
Guys, it is clear.
Yes, sir.
Please
Equation
make
மட்டும்
சரியா தெரியலையா?
equation மட்டும் sir.
எதுடா லாஸ்ட் ஈக்குவேஷனா ஃபுல்லாவேவா?
Last equation. I am writing here. V is equal to EB plus ISC into RSC and then plus IA into RA. This is the last equation. Now it's clear? Is it okay?
Okay.
Yes, ma'am.
Okay. And then next, moving to the cumulative compound motor and differential compound motor. Have you all noted down? Shall I erase this?
1 minute, ma'am.
Okay.
Madhyarasan? Whose voice is slow? என்னோடதா இல்ல மேமுதா?
Sir?
The voice is slow னு சொல்லிருக்காங்க.
Okay, okay.
இப்போ பரவாயில்ல சார்.
Okay, மதி. Okay.
Let me know if you are completed, then only I can erase the board.
Please make note of it. It will be useful for your lab session. We are having these experiments also regarding shunt and compound series motor and all. So during that session, this formula will be useful. So please make note of it.
I think they have copied the Langshan, so I have erasing the Langshan. The next one is cumulative.
Wait a minute. They are asking 1 minute now.
Okay. Have you all completed? Have you all?
Yes, did you completed? We'll move on to the next cumulative. Yes, ma'am, you will carry on. Ma'am.
Okay. Cumulative compound motor is nothing but I have for this limb I can connect the both series as well as shunt winding. So what is that? If the current direction is same, it will be adding each other. Cumulative means it is adding. So the both fluxes of shunt and series will be adding each other. The flux value will be high. If my flux value will be very high, means the torque value is increasing. If torque is increasing, my speed also increasing. So the cumulative compound motor I can use for the high power application. I'm repeating once again. See, another one is cumulative. If I'm connecting the both series as well as shunt winding together to the in field, if the connection, if the fluxes and current will be the same direction, so it will be adding together. I can add my ISH plus ISE. So that is called cumulative compound motor. So the fluxes will be added and then current, the both are in the same direction. That is called cumulative compound motor. For differential, the same, but only one difference, the current direction will be differing, opposite to each other. So that condition, so this is my ISH and then if it is my ISC, so I'm repeating once again, if it is connected in same, if both series and shunt winding connected together, if both current is same direction, so it will be added together. So that is called ISS plus ISE is adding together. So that is called, it is called cumulative compound motor. if the current direction will be differing, so what will happen? It will be opposing each other. So it is minus ISH and then it's minus ISE. It will start to oppose each other. So what will happen? There is some lot of flux will be produced here. So maximum we want this type of differential compound motor. For rare application only, we can use the differential compound motor because it is opposing each other. So it produces the more fluxes. So it will be runs at a high speed instead of cumulative motor. Instead of cumulative motor, differential motor will be run at a very dangerously high speed. So because Y means here the both current will be opposing each other, so it will produce the more number of flux, and then if the flux will be increasing, the output will be increasing. So what will happen? The output torque and then speed will be increasing. So the normally in differential compound motor is for
Yeah, ma'am.
Yes, sir.
Ma'am, if you write in downside means there is blurring, ma'am.
Okay,
So
sir.
use stress, ma'am.
Is it clear? Differential compound motor diagram is clear, or shall I erase and then redo again?
Erase, ma'am.
Okay. The same I can connect for the cumulative differential also, but only one difference. It is connected opposite together, which means here it is the current direction will be same. For cumulative, the both shunt and series current will be direction will be same, which means it will be cumulative. It will be added together. So that is called. That's why it is named as cumulative. So it's nothing but sum of the current. So the flux will be added together. The same way for differential, here the current direction will be differing. It will be minus plus and minus plus. So it will be what will happen? It will start to opposing each other. So the both current and then flux opposing each other. So it will be produce the high amount of flux. So what will happen? It will be run at a dangerously high speed. So normally for special application only, I can use the differential compound motor. For special application only, I can use this type of motor because normally the shunt and series current will be opposing each other. So it will be producing the large number of flux. So it will be run at a dangerously high speed. So it will be rarely used. But cumulative we can use all over. Is it clear? There is no voltage and then current equation for this cumulative and differential. You just know the concept of what is meant by cumulative and then what is meant by differential. That is enough. No need to worry about the voltage equation and then current equation of the cumulative and differential motor. They won't ask normally. Is it clear? If two current is connected same direction means it started to adding. It will be adding together. That is called cumulative. Cumulative means summing. Cumulative means you used to say it's a summing. Also, it is cumulative compound motor. So the name itself differential means it started to opposing each other. The both direction will be differing. So it started to opposing each other. So it will produce the large number of flux. If the flux is very high, then what will happen? The speed also very high compared to the differential compound motor. Is it clear?
Yes, if you are having any doubt, please ask regarding the long shunt, short shunt, and cumulative differential. This long shunt and short shunt are very important questions.
Yes? Any doubt in it?
Did you copy it?
Have you all copied?
Yes, please respond. Yes. Yes, sir. Yes, sir. Okay.
மேம் குமுலேட்டிவ் ஈக்குவேஷன் கொஞ்சம் பெருசா இருக்குங்க மேம்.
I didn't write any equation, Ra.
Like IGH.
Nothing else. ISH, nothing else. It can be the two currents will be added together. The first current is ISH, the another current is ISC. That's why I have write it as ISH plus ISC. We know that it is shunt and series. If it is flow in the shunt means you can write it as ISH. If the current flowing towards in the series field winding, you can write it as ISC, nothing else.
Clear?
Yes? Is it clear? See, normally instead of I, you can write it as flux. It will be better.
Okay, ma'am.
Yes.
So you
Have you
can
all
move on.
copied?
Yes, did you copy?
If you copied, means I can move to the characteristics of the shunt motor.
Yes, ma'am. We will move to the next topic.
Yes, the next one is characteristics of the shunt motor. So before going to the topic, you should know that two basic formula, torque equation as well as voltage equation, and then speed, how the speed and then flux will be varying, and then how the torque will be varying with respect to flux and all. What is the torque equation of the DC motor? Last class I have said, I have derived the torque equation. Somebody unmute and say what is the torque equation of DC motor?
333. Well, Vignesh, can you answer the ma'am's question? What is the torque equation of the motor, DC motor? 333. Can you unmute?
What is the torque equation of DC motor?
If you are not telling means we will mark it as absent for you. Krishna and Kishore. 316 Krishna and Kishore. Three 116.
See, who knows the answer?
Yeah. Not answering means we will mark it as absent for you people.
Somebody who knows the torque equation, somebody unmute and say.
Basic questions, but you are not answering. Otherwise, we will mark you for absent for you people. 330.
Yes. Have you all copied the last class notes? Somebody unmute and say, have you all copied the last class notes?
Okay, Partha
Then I
sir,
have.
Partha sir, you are only answering the questions. None other than anyone didn't answer any questions.
What is the torque equation?
Three not five.
Sir.
Answer the question. Do you know what is the torque equation? Did you copy the torque equation formula?
No.
Did you copy the torque equation formula?
Hi, sir.
What is the torque equation?
TA is equal to
Hmm.
1 by 2 by
Hmm.
L by A, PZ by A.
L by A. This is what I taught in the last class. Where I have write it as L by A. Listen, torque is directly torque equal to
It's I by A,
1
not a
divided
L
by
by A. It's IA. Okay. It's no.
pi IA into PZ by A. This is the torque equation which I taught in the last class. Here 2 pi is constant and P is constant and Z is constant and A is constant. So torque is directly proportional to pi IA. This is the equation I have expecting from you. So no one is telling what I am teaching yesterday. Is it so? Now what is the use of I am taking class here? So torque is directly proportional to pi IA. Rewinding the last class, I have deriving the equation part torque. So I have took for the one revolution. From this I can take from the power and then P is equal to T omega. I can substitute the P instead of V into I and then V into T into omega. The omega is nothing but 2 pi n by 60. There I can derive the equation. The T is nothing but 1 divided by 2 pi pi IA PZ by A. Here P, number of pole is constant and armature conductor is constant and A is constant and 2 pi always constant. So I can write it as my torque is directly proportional to flux into armature. This is the equation I am expecting from you. So no one is ready to telling. And the next one, I'm going to interlink with how the speed will be linked with the torque. Again, the same equation I'm writing here. Please note it down. We know that EB is equal to V minus IA RA. Here, this equation I can write it from the V is equal to EB plus IRA. The same voltage equation I'm rearranging with respect to EB. So, if I'm rearranging this, what will happen? EB will come this side, so it will be minus V plus IARA. So, I can rearrange it is equal to V minus IARA. This is my EB equation. So, what is the next step? We know that what is meant by EB. What is the formula EB back EMF formula in F? What is back EMF? What is the formula to find out back EMF? What is the formula?
Pi PNZ
Pi PNZ
I P N Z by
divided by
68.
60A, which is equal to V minus IA into RA. Am I right? Yes. So, what is the next step? What is the next step? So, I can write it as here. What are these constant? What are here is the constant. Here, P is constant. Are you agree that number of pole is constant? And then Z also constant. And then 60 also constant. And A also constant. So if I keep on changing the current value or if I keep on changing the load, it won't affect on the number of pole and armature conductor and 68. It is already fixed because while designing or while construction of the motor, the values will be same. We won't change. Yes or no? Or you agree that every time we cannot change the armature conductor. If it is armature conductor is 1280, it is constant for whenever we are running. The number of pole and armature conductor is constant because they have fitted in the construction wise itself. So here I can write it as here my n and pi will be varying with respect to V minus IA into RA. Are you agree that? So I need n value, speed n is equal to V minus IA into RA divided by, it will come this side, it will be pi. So this is my voltage speed equation. So I can write it as N. What is my V minus IARA? I can replace V minus IARA instead of C and tell. C and tell, what is V minus IARA? Yes?
Speed.
I'm going to replace V minus IARA with respect to another term. So I can write it as V minus IARA with respect to see the derivation and say how I'm going to write V minus IARA.
EP, ma'am.
Yes?
EP.
Yes, this is back EMF. So N is equal to, because I have write it here, EB equal to V minus IARA. So it is EB by pi. This is my speed equation with respect to flux and then back EMF. So if flux is decreasing, my speed will be increasing. Is it clear? It is inversely proportional. Yes? Have you all understood what I'm trying to say? If I'm keep on increasing, so if I'm increasing my flux, what will happen? It is inversely proportional. If I'm increasing the current value, because if I'm passing the current only, flux will be produced. Yes, are you agree that in the point current irundana, flux will be produced. So if I'm changing the current, if I'm increasing the current, the flux will be increasing. If my flux will be increasing, what will happen to my speed? Whether it will be increasing or decreasing?
Decreasing.
Yes, because it is inversely proportional. So if I'm increasing the flux, and then the torque will be, speed will be decreasing. But here, see this, if I'm increasing the flux, what will happen to my torque? Have you all got my point? If I'm increasing the flux, what will happen to the torque?
Torque will be decreased.
Decreasing. It is inversely proportional or directly proportional?
Torque is directly proportional to flux.
So
it increases.
Flux will be increases, the torque will be also increases. Are you agree that point? What I'm teaching here, have you all understood? Have you all understood? Yes?
Yes, ma'am.
Have you all copied the formula? If you know
Yes,
this
ma'am.
formula, and then if you know if I'm increasing the flux, what will happen to the speed, then only you can draw the characteristics of the DC shunt motor and series motor and common motor. If you don't know about the what is the relation between the speed as well as flux, and then if you don't know about the torque is directly proportional to pi Ia, there is no need to go with the characteristics of the shunt motor. So before, you should know how it will be related to the flux and the torque. This is the main thing you have to know. The same way here also. So now say how torque and speed will be related with this equation. Now say how torque and speed will be relevant to the equation. Can you interlink with torque, T and N? How it will be interlinked?
Depend on flux.
It is common for flux only. I'm asking how you interlink the N with respect to T with the equation. This
Torque increase means speed decrease ஆகும் மேம். Hello ma'am.
Ma'am, torque இதுல torqueல வந்து
Torque increase ஆனா speed decrease ஆகும் ma'am.
Pardon, I didn't understand.
Yes? Torque increase means speed decrease ma'am.
Yes, definitely. Who said?
Chandru ma'am.
Yes, Chandru is correct. N is inversely proportional to 1 by T because my T is directly proportional to pi IA. So I can write it as here T. So N is inversely proportional to the torque. This is the third equation. So from 1 and then 2 and then 3. If you know these three equations, you can definitely easily understand the characteristics of the shunt motor. Yes? Have you all? Is it clear? Have you all? How many of the there in the class?
85.
85 out of 2, 83, all 83 students have all understood what is meant by torque and speed and then flux.
Yes, ma'am.
Relevant to the, yes. Shall I move to the characteristics of the shunt motor? So now you are
Yes,
going
ma'am.
to say, you are going to draw the characteristics of the shunt motor. I won't do anything. Just I will say the concept. So you are helping to draw the characteristics. Okay, va? Yes. So for your reference, I'm going to write the three equation from once again, and then I am going to draw the shunt motor characteristics. Okay. Please copy as soon as possible. Then only I can move to the next topic. Once you finish, let me know. Then only I can erase the board and then I move to the next topic. If you know the concept, you can easily understand in the lab session also, because there I'm going to say the load characteristics. There again the speed and torque will play a vital role. So if you know that, you can easily draw, you can easily do the experiment in the lab. All of you finished? All of you? Shall I erase the board? Shall I erase the board?
Yes. Did you copy it? Ma'am.
Yes, yes. Yes. You need one more minute?
Oh, they have copied.
Okay, okay. I'm writing here. I make it as fast. Yes? I'll quickly copy the notes.
This one we can erase it, ma'am.
Okay, okay. So next one, characteristic equation of DC shunt motor. I'm going to draw for only the DC shunt motor. There is three characteristics. I'm simply saying how it is, and then you have to draw. I will help you, and then you will help me. I will draw here in the board. The first one is speed and armature current characteristics. It's nothing but IA and then T. Is it visible? And then second one, a torque and then IA. And then last one, here I'm drawing here. Is it clear? The last one is N with respect to T. Is it clear? Simply, I'm going to say this is nothing but torque, armature, I'm repeating. Sorry, it is N. It's nothing but torque and then armature current and then N speed and then armature current and then N with respect to torque. Now you say, now I'm going to increasing my IA, what will happen to my torque? See the equation and say, if I'm increasing the armature current, what will happen to my torque?
Increase, ma'am.
So how the graph will be look like this? How it will be? Any guesses? Just say. That's enough.
Curve. Curve, ma'am.
Curve means all we used to say is a curve. How curve?
Upside down.
No, it will be
zero and
increasing.
increase ஆகும் மேம்.
Yes, this is the torque armature current, because we know that torque is directly proportional to pi Ia. If I'm increasing Ia, the torque is obviously increasing. So if I'm increasing Ia, it will be started to increasing, nothing else. Yes? So any doubt in it? Is it okay
No,
or
ma'am.
not?
Yes, ma'am.
Shall I move to the next one?
Yes, ma'am.
So now I'm going to increase the armature current. What will happen to my speed?
Increases.
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 Increases or decreases?
Decrease ஆகும் ma'am.
How?
How you're telling that it is decreases?
Say it's correct answer only. How you are saying it is decreasing?
And because flux is inversely proportional
Yes,
to
yes. So it will started to decreasing like this. Before that, shunt motor is a constant speed motor. Every time it will be runs on the 1500 RPM. It's a constant speed, any speed. So while starting a shunt motor, you have to set some constant speed. After that only you are going to increasing the armature current. The concept is correct because N is directly proportional to EB by pi. If I'm increasing by IA, what will happen? My flux will be increasing. So if my flux will be increasing, what will happen to my speed? Speed will be decreasing. So it is N is inversely proportional to armature current. Is it clear?
Repeat it once again. Once again.
I'm repeating. If I'm increasing the IA, what will happen to my flux?
Decreases.
Increases. See, if current will be increasing, what will happen? Then only flux will be producing. Are you agree that current irundha flux irukum? Current ni coil ku pass panna appadina, there is no flux will be produced. So if I'm increasing the armature current, the flux will be increasing. Are you agree that?
Yes, ma'am. Yes, ma'am.
Yes. If my flux will be increasing, what will happen to my speed? N is inversely proportional to pi. If pi is increasing, N is obviously decreasing.
Decrease.
Yes. So again, the shunt motor, the another name of shunt motor is constant speed motor, because it will be run only the constant speed. So every time you have to run the shunt motor, before that you have to set some constant speed. Normally we have to set in the 1500 RPM. It's a rated speed. You have to set in terms of the rated speed 1500 RPM. So if I'm setting the 1500 RPM, what will happen? If I'm keep on increasing my armature current, so the speed will be started to decreasing. Yes? Yes? Is it clear?
Yes, ma'am.
Okay, shall I move to the last one?
Ma'am,
Yes, ma'am.
Yes.
Any doubt?
ma'am,
Any
அது
doubt?
constant speed motor தானே மேம்?
ஆமா.
அப்புறம் எப்படி மேம் ஸ்பீட் டிக்ரீஸ் ஆகும்?
லோட் கொடுக்க
கொடுக்க டிக்ரீஸ் ஆகும். You are giving
See,
load.
listen, if you are traveling, இப்போ நீ வந்து பைக் வண்டியில போயிட்டு இருக்க, ஒருத்தர் வச்சுட்டு நீ ஓட்டிட்டு இருக்க, ஸ்பீட் எப்படி இருக்கும்?
ஸ்பீடா இருக்கும் மேம்.
ஸ்பீடா இருக்கும். அவனோட ஃப்ரெண்ட் 4 பேர்த்த ஏத்திட்டு போறவனோட ஸ்பீட் எப்படி இருக்கும்?
கம்மியாகும் மேம்.
அப்ப இந்த மோட்டார் நான் ரன் பண்ணிட்டு இருக்கேன், கான்ஸ்டன்ட் ஸ்பீட்ல ரன் ஆயிட்டு இருக்கு. If I'm increasing load, what will happen?
Decrease or speed decrease.
So, yes, that's why I'm saying. That is the
Giving
concept.
load,
Okay, ma'am.
Okay, wow.
load group. If you are giving load,
Load
means,
if yes, sir, point is correct. Saying, sir.
giving load means the speed will be decreases. Okay. Yeah, we are giving load continuously. We are increasing the load. Step by step, we are increasing the load means automatically the speed of the motor will be decreases. Okay. For example, you are taking the mixie as example, or as any home appliances as example. If you are driving the mixie without any load, any particles in it, mixie will run faster. If you kept any particle in it, mixie run at same speed.
No, sir. Speed decrease.
Yes.
That's the concept.
That is the concept. If you are not increasing or decreasing the load, means it started to run at a constant speed only. If once you are going to increase the load, means there will be some decreases will occur. That's all.
Could you give some other example?
You need another example?
So,
Yes,
yes,
the drive.
with respect to
No, I think that drive vandi best example da enna keta. Yes, if you are going single, you can drive any speed. If the numbers will be the எப்படி சொல்றது ஒரு 4-5 பேர் ஏத்திட்டு போகணும் அப்படின்னா what will happen? The speed will be decreasing. Load கொடுக்க you cannot run at a constant speed. If you are keep on adding the one person, what will happen? The speed will be started to decreasing, nothing else. Sir said the nice example. So Star told the mixie. That is another example.
Another example means if you are running without any load, your load எல்லாம் தனியா ரன் பண்றேன்னு வச்சுக்குவேன். ஓகேவா? சும்மா ரன் பண்ற. உன்னால எவ்வளவு ஸ்பீட் போக முடியும்? அதே ஒரு 10 கிலோ இல்ல 20 கிலோ வச்சு ரன் பண்ற. சேம் ஸ்பீட் அச்சீவ் பண்ண முடியுமா உன்னால?
This is another good example.
Large version. Can you get the point? So you can relate with the. Can you relate with the? Agree or not? Did you agree or not? If you are running without any load, or else you can run with the 20 kgs or 30 kgs in your backside. Did you achieve same speed?
No, sir. No, sir.
Definitely no. Okay. So we can relate with this. Okay. So if you are coming to lab session means we are having this practical example of it, because we are giving a load with the help of the spring balance means it is practically it is proved. Okay, proved to you. Okay, that the speed and current, with respect to speed and current, if you are running the lab session, we can practically prove that the speed and the torque. Okay, current, speed and the current.
Yes.
Okay, sir.
I hope you are all clarified. And then I'm going to the next topic. The next topic is again the torque with respect to speed. How the graph will be look like. See, link with this torque and speed. It's whether it's if I'm increasing torque, what will happen to my speed?
Decrease, ma'am. Decreases.
Decreases. See the formula and say. So what will happen? It's a constant speed motor. So again you have to draw the constant line. So it is same as the before diagram. Idu same other epome. This is the DC shunt motor characteristics. Have you all understood? Have you all?
Yes, ma'am.
So this is what you are going to do in the lab session also. If you know the concept, you can easily do the lab session also, because there the load test on shunt motor is there. There you have to use this, you have to draw the graph. So there you can, if the concept is clear, we can easily do in the lab session also. And then I hope all are know about the characteristic of the shunt motor. And then shall I move to the series motor? Yes. Shall I move to the next one? Series motor. So this is the torque armature current characteristics. Here speed armature current characteristics. Here speed torque characteristics. We know that N is equal to speed, T is equal to torque, IA is nothing but armature current, again N is speed. So combined together, you can write it as, you can say it as torque armature current and speed armature current and speed torque characteristics. That's it. Sometimes they have asked you have to draw the speed torque characteristics of the DC shunt motor. So you have to draw the speed torque characteristics here, N and D. So please
These are important questions regarding the both CA and the some point of view. Okay.
Please
Taking
write
any
the
question means there will be some electrical and mechanical characteristics of a DC motor. Sure question. So please make note of it.
write in the written notes also, because they have find while exam point of view may forget, please note it down. Torque armature current characteristics, here speed and then armature current characteristics. Characteristics, please note it down. The same way it is speed torque characteristics. That's all about the DC shunt motor characteristics. If you are completed, then I can move to the series motor. Yes. Shall I move to the next one?
This one we will move to series motor now.
Yes, sir.
I hope they are copied.
Again, the same. I simply erase the graph only, because other also same. We are going to draw the same characteristics only. So I simply erasing the, but you have to do separately in your note. I'm going to draw the same characteristics only. DC series motor. Here the only one thing is differing, and then this is also. Yes. So what is the series motor diagram? எப்படி வரும் series motor? How the connections will be?
Can anyone explain the term of
Field
series
winding and
motor?
armature winding are series.
Yeah, very good.
So I can draw the graph. See, I can draw the diagram. It will be correct. Am I correct? This is my ISC and this is my IA. This is my IL. Am I correct?
Yes, ma'am.
Yes. Here, what is the another thing? Means here my torque is directly proportional to pi Ia. Here my flux is directly proportional to armature current, because here it is connected in series. So what will happen? The flux is directly proportional to armature current. So I can write it as pi is equal to Ia. So what will happen? Instead of pi, I can substitute Ia. So T is directly proportional to Ia into Ia. So that is nothing but T is directly proportional to Ia squared.
This is the thing we want to change it.
Yes. I'm repeating once again. In series motor, There shunt field motor. Here the field and the armature will be differing. There is a field current will come and then armature current will be coming because it is connected in parallel. So the flux will be occurring both field and armature. But here it is connected in series. My flux is directly proportional to IA. So I can write it as pi is equal to IA. We know that formula T is directly proportional to pi IA. Instead of pi, I can substitute IA. So T is directly proportional to IA squared. Yes? Is it clear now?
Yes, can you able to follow it? Please chat in chat
All of
box.
you can able to
answer
follow how I'm writing this equation. Is it clear or shall I repeat once again? How have I got the T is directly proportional to IA squared?
Ma'am, once again, ma'am.
Yes. Listen, in shunt motor, the flux will be differing both on field and armature. Are you agree that? Because here current will be dividing. So there is some current, ISH current will be flowing this and then IA current will be flowing. Is it clear? If it is connected in parallel, the current will be dividing. Are you agree my point?
Yes, ma'am.
So the same way here, the series winding, the series current and then armature current will be equal. So my pi is directly proportional to. So the current will be same. So the flux will be directly proportional to IA. I can write it as IA. Are you agree that? Because whenever I am giving current, then only flux will be producing. Yes. Here the current will be equal. My IL equal to ISC equal to IA. Am I correct? Because the both are connected in series, so IL current equal to ISC current equal to IA. Three currents are same. Every time you have to say with respect to armature current only. So I can write it as pi in terms of IA. Am I correct?
Yes, ma'am.
So we know that formula T is directly proportional to pi IA. Here instead of pi, I can substitute IA. So T is directly proportional to IA into IA. So T is directly proportional to IA squared. Yes?
Yes, ma'am.
So the next one, coming to that, so is T is directly proportional to IA squared. So my N is directly proportional to 1 by square root of T, nothing else. Because coming to the here, what will happen? My pi will be twice. So if it is IA squared, the flux will be twice the time. Are you agree that? Current will be twice means the flux will be produced in the twice time only.
Yes.
So I can write it as N with respect to 1 by T. The torque will be produced in the twice the time only because this T is proportional to IA squared. So torque will be produced in the twice the time. So I can write it as N in terms of 1 by square root of T. Yes?
Yes, ma'am.
Okay. So this is the concept you have to know before entering to the series motor. Again, there's another concept we have to know the series motor. The last shunt motor I have told, shunt motor is constant motor. Every time while running a shunt motor, you have to set the rated speed 1500 RPM. But in this case, we cannot apply the constant speed because it is series motor. It is run, basically it runs at the twice the time. So what will happen? IA is nothing but starting current. If my starting current is twice the time, the torque will be twice the time. So it will be run at a dangerously high speed. So every time while starting a series motor, you have to give some load in order to reduce the speed of the motor. I'm repeating once again. As IA is nothing but starting current. So normally, if I'm giving some current, if I'm giving current are 2 amps, so what will happen in series motor? It will take the twice the time. So 2 squared, it will be 4. If my current will be increasing, starting current will be very high, means my starting torque also will be very high. Okay, if my starting current will be very high, means the machine will be run at a dangerously high speed. So in order to avoid that, every time you have to run the series motor with some load. Without load, you cannot. You can turn on the series motor, but it will be run very heavily. It may be it run at 3000 or 3500 RPM. So in order to avoid that, if my machine is starting itself, it will be started to run 3500 RPM. What will happen? It will be damaging the winding of the motor. In order to avoid that, I have to start with some motor. So in order to avoid that, I have to start the series motor with some load. Have you all got my point? Is it clear? I think you won't understand. Shall I repeat once again?
No, it's clear.
It's clear.
Yes, ma'am.
Yes?
Yes, ma'am.
Ma'am, I got out.
Yes.
Ma'am, in DC shunt motor, torque increase means speed decrease, no, ma'am.
Yes.
Up
But I didn't interlink with the torque and all. Normally, we know that formula. What is the formula? V is equal to EB minus IA into RA. There, if the starting current will be high, and then what will happen? My voltage will be increasing. So every time you have to run the motor with some less current and then less torque, or what is that? Less speed. So for example, you have to take a fan. If I now fan switch போட்டோனே என்னோட fan வேகமா ஓடிச்சுனா, you can agree that. Or if it is for grinder and mixie, if it is done at the starting with very high speed, have you agreed that? Have you buy this type of? So every time while starting, you have to give the less starting current. So for this only, I have moved with the starting point. The starting point is nothing but starter.
This imagine thing. What is this? IA. What is meant by IA? Anyone tell what is meant by IA?
armature current.
Armature current.
Okay. But imagine the square root of armature current. So what will happen if we on the motor with square root of current means everything will blown off. Okay. For example, if we don't load the series motor with the loader condition, we can on the series motor means sometimes it may break the windings or else motor will be blown off.
Once again, I will be clearly saying the another one. From this, you can can able to understand what is meant by armature current. Here, while starting, this is the voltage equation of the DC motor. While starting, there is no back EMF. So while starting, there is no back EMF means the EB can be 0. I can write it as V is equal to IA into RA. Sorry, IA into RA. So from this, I can derive the starting current IA. IA is equal to V by RA. So normally, you have to consider the. So I said armature part. So armature part only we have to consider. There only the flux will be adding together. So there is a rotating. What is that? EMF will be induced as well as the torque will be induced in the armature part only. So every time you have to consider the armature is the starting current and starting torque. Have you agreed that if you are varying the armature, you can control the starting current? Yes, from this only you can get the output. Yes, from the armature only you can able to get the output. So I can control the armature, I can control the starting current also. Are you agree that? Because the field flux will be moved to the armature. In the armature only the fluxes will be added together. There only the EMF and then what is that? Output, the torque will be induced. So if I am varying the armature, I can control the starting current and starting torque also. So that's why all the textbooks, all the we can add the armature resistance. We can add the resistance, then I can control the current, starting current. So if I'm increasing the resistance, what will happen? If I'm increasing resistance, what will happen? My starting current will be started to decreasing. That's why I have added a starter in the start the motor. This is the another concept I will teach once clearly while moving to the starter part, because there is a without starter we cannot start the motor. So there you can use this concept. Now you can understand what is meant by armature current. This is the starting current. If the starting, while I am saying means T is directly proportional to Ia squared. If my starting current will be double the time, means what will happen? My starting current will be very high. So if the starting current will be very high, means my voltage will be very high. Voltage is high means my speed will be very high. Yes?
Yes, ma'am.
So if my series motor will be started twice the current, so it will be started to run at a dangerously high speed. In order to avoid that, I have to start the series motor with some load.
Load of condition.
Yes? Are you all able to follow the armature current and all? Because V is directly proportional to I. So if I'm increasing the armature current, voltage will be increasing. If voltage is increasing, my speed will be increasing, because N is directly proportional to V minus Ia Ra. So N is directly proportional to V. We know that N is equal to EB by pi. So EB is nothing but V minus Ia Ra. So N is directly proportional to V. Do you agree my point? So if a starting current, while starting my armature current will be twice, means the voltage will be increasing. If my voltage is increasing, what will happen to the speed? Speed will be increasing. So the series motor without starter, or with even though I have started with the starter also, we cannot able to control the speed, the starting current of the series motor. So every time you have to start with some load. Then only you can reduce the speed, because if I'm increasing the load, what will happen? Speed. If I'm increasing the load, what will happen to my speed?
Decrease, ma'am.
So the same concept. If I'm increasing, you have to start with some load, means the series motor the speed will be reduced somehow. Are you able to my concept?
Yes, if we are moving to lab means we will clarify it. So seeing this equation means you will be not able to follow it. And when doing the experiment, you will experience it lively. Okay, how the speed changes, how the torque changes, and all we can experience it. Clear?
Yes.
Yes, sir.
Have you all understood what I'm trying to say in the series motor, regarding series motor? Have you all understood?
Yes, ma'am. கொஞ்சம் ஸ்லோவா
Keep it in
சொன்னீங்கன்னா
mind.
இன்னும் கொஞ்சம்
Slower, okay, I'm repeating once again.
மேம் ரிப்பீட் பண்ண இதுவே புரிஞ்சது மேம் இனிமே நடத்தையில ஸ்லோவா சொன்னீங்க
Okay.
So you want to keep it in mind that you want to don't start the motor, series motor without preload. Okay, every time you are on the series motor and we are during the lab session, you want to connect with some load. Then only motor will not attain very dangerous speed. Otherwise, it will attain the dangerous speed. So just relate with it. Clear?
எஸ் சார்
So
எஸ் சார்
relate with the equations.
So this is what I tried to say in the why it should not started with some load. So that's why I'm saying. I hope you are all understood from this equation. I hope so. Have you all noted down? The series motor should not start with some load. Have you all noted down? Yes. Yes or no? Somebody unmute and say, have you all understood? Then only I can move to the characteristics of the series motor.
Anybody? Do you understand?
Have you all understood or not?
எஸ் மேம்
Yes. So series motor, you have to start with some load. Then only you can control the speed of the motor. So I am erasing it. Have you all noted down the equation? I will say clearly once again while teaching the starting of the motor. Again, this equation I will repeating once again. Before that, you should know how it will be interlinked with the D series motor. Please copy this also. While teaching a starter, I will make question from this equation. Yes? Shall I ask this? Shall I erase? Okay. And then next I'm moving to the characteristics of the series motor. So now you say, if I'm increasing the armature current, what will happen to my torque?
Increases.
Increases. So it is same as the shunt motor, but it's twice, so it will be started to like this. Nothing else. It has some curve, which means it indicating the IA square, nothing else. Okay? The same only. Because if I'm increasing IA, the torque will be increasing. It's the same graph, but it has some curve. So what will happen to the IA with respect to N? What will happen?
Increases.
If I'm increasing IA, what will happen to my speed?
Increases.
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 N is directly proportional to EB by pi means what will happen if I'm increasing armature
Decreases.
current? Flux will be increasing, so N will be decreasing. So how the graph will look like? Dirko? Just think and say. If it is wrong, no problem. I will teach you again. How the graph will look like. Yes? Yes? Any doubt? It will be because we don't know the value of the speed of the motor, because we have starting the series motor with some load, it will be run at some speed. If I'm increasing IA, it will start to decreasing like this. Yes? Are you agree my point? So what will happen to this graph? N speed torque characteristics. See the shunt motor and say how it will be look like this.
Decrease.
Yes, it is follow the same graph as N into IA. So it will be same as, it is both are same.
Okay.
Yes.
You able to follow it?
Any doubt, please ask now itself. I will repeat once again and then I can move to the next topic. If you don't know about the concept, there is no need of going to the next topic. Yes, sir.
It's already 3:25, ma'am. We will move to the lab
Okay,
session.
okay, sir. Yes, sir. Yes.
If you are having any doubt, please ask us, or else we can move on to the lab session.
This is the last topic. I have stopped here. The next I'm moving to the lab session. If you have any doubt, please ask now itself. If you won't ask any doubt, means next class I will start from the question itself. Definitely I will ask why the DC series motor should start with some load. And then why it is T is equal to IA squared. And then why it is 9 is directly proportional to 1 by square root of T. I have to definitely I will ask, then only I will move to the, I will take the next topic for Friday. Have you all understood clearly what is mean by torque and then speed and then armature current, back EMF and all?
Yes, ma'am.
There is no doubt.
No, ma'am.
Able to follow it? And able to follow it?
Yes, sir.
Yes, I think Chandru only replying. Others are keeping simply there in the meet. Others, there is a one girl in the mechanical department. I think so. Where is she? Unmute and talk.
I think she is absent today.
I didn't see her till now.
I think she is absent, ma'am.
Okay, sir. Okay, sir. Is it clear, all of you?
Because if you are clear,
Eight entries.
lateral entries will be able to follow the things. That is Balaji,
Balaji.
Sir.
Gauri. Are you able to follow the things? What is going on here? Can you able to follow it?
Yes, sir.
Yes.
Yes, from this I stopped the theory session and then next I'm moving to the lab session. The lab session last I have discussed about the Shanton series motor only. I have skipped all those things. Straight away I'm moving to the lab experiment. So today I'm going to talk about the speed control of DC shunt motor by field resistant and armature resistant control. Have you all copied the notes? I think yes. So I have erasing all those things. I will teach the theory part and then Sar will do the virtual lab. For this, you have to go with the virtuallab.co.in that website. I will teach the theory part. Then only you have to do in your own. You have to submit the soft copy of the field control experiment. Then only we have give the marks. Okay. So the topic is speed control of DC shunt motor. This is the experiment. I will draw the circuit diagram and then I will teach. Listen. the speed control of DC shunt motor. Again, it's a DC. So I have give the supply is plus minus. Plus minus means it is a DC supply. So all the ammeter and voltmeter will be in DC. So it will be A and B under the direct line. So which means we have connected the DC ammeter and then DC voltmeter. Is it clear? So the next one, what is LFA? Any guesses? This is the motor. A1, A2 is nothing but armature winding, and then F1, F2 is nothing but series winding. So field winding, armature winding is connected in parallel. So it is called shunt motor. Are you agree my point? Are you agree
Guys,
my point?
answer the question. Anybody unmute and answer. Are you
ma'am.
able to follow the things?
I'm
Yes,
going
ma'am.
to this step by step only. Please follow my words and then please make a note of it. So if it is field winding, it is armature winding, because every time I have said the A1, A2 will have come inside. So every time you have to draw the motor, then you can write it as A1 and A2. And then it is field winding, F1, F2, both are connected in parallel. So it is called shunt motor. Is it clear? Is it clear or not?
Clear?
And then, is it clear?
Yes, ma'am.
Yes. Have you any guess what is meant by LFA? What is that actually?
So,
Any guess? Please say, and then I will say, I will. So what is mean by LFA? Any guesses? Just think and say. It is relevant to what I'm talking before.
Load flex.
load. Load flexor.
So listen, leave that. There's nothing but a starter. I had said without starter, I cannot able to start the motor. So I have to connect the starter here. This is called 3-point starter because it has L is nothing but line, F is nothing but field, A is nothing but armature. Please note it down clearly. L is nothing but line, F is nothing but field, A is nothing but armature. It's a 3-point starter. Okay, why it is 3-point? I will say a bit about the 2-point starter and 3-point starter and 4-point starter. Here we know that this is the shunt motor because it is connected in parallel. You have to connect both field as armature is separately. So it is F and then which is A. Again, I have to give supply, so that is but L. If it is series motor, my diagram will be so I can connect one point to this part because it is same. So I can take it as A. I have to give supply to L. So while starting a series motor, I need 2-point starter. While moving to the shunt motor only, I have to give supply to field and armature also. So I have used for the LFA 3-point starter. And then while moving to the compound motor, I am going to the 4-point starter. This is the basic thing. And I'm just saying why LFA and all. While teaching the starting of motor, I will teach neatly about LFA and LA and all. So, what is starter means? In order to reduce the starting current of the shunt motor and series motor, I have connected the starter here. Without starter, it has some large number of starting current. So what will happen if I'm starting the motor without starter means the starting current will be very high. So the voltage will be high. So voltage is directly proportional to the speed. So speed will be very high. If my machine is starting itself, it started to run at a above speed. So what will happen? There is a damage will be occurring to the winding. In order to prevent that, I have using the starter in order to limit the starting current. Is it clear? Is it clear?
Yes.
Yes. So it is a shunt motor. So I have connected 3-point starter here. L is nothing but line. From the supply, I can given to the starter, and then from the starter, I can run the motor. So here is field. I have connected to the rheostat, followed by current ammeter, and then followed by field. The same way, armature is connected to the rheostat, followed by armature winding is parallel to the voltage. See, I will say what is mean by rheostat and why it is connected armature, ammeter and voltmeter and all. Rheostat is nothing but it is a resistance. Again, rheostat is another type of resistance. I can say it's a resistance also. I can vary the resistance. So it is called rheostat. So normally you can say it's a resistance also, nothing else. Yes?
Yes, ma'am. Ma'am, அதே மேம் இன்னொரு சைடு கனெக்ட் ஆகாம இருக்கு.
Yes.
மேம் another side கனெக்ட் ஆகாம one side மட்டும் கனெக்ட் பண்ணி வச்சிருக்கேன்.
No, it is a position that is minimum and maximum position.
Yes, I will say nothing else. It is the one point. While moving to the virtual lab, you can understand. Sir will teach you how it will be connected, how it will be going to connect and all. I will say it has 2 points only. It is the minimum position. If I connected to starting point means it is the minimum. For this condition, you have to check it is connected to the maximum point.
So it is maximum.
This is maximum.
Clear?
Is it clear?
Ma'am, once again.
Nothing else. It's a one type of load. You can say it's a resistance also, nothing else. I have connected with respect to field. While the starting resistance should be low for the field, so I have connected to the minimum. So minimum means you have to connect to the this part. So I have starting from, I have connected this. Here I have connected the ammeter. Field, I can measure the current. For armature, I can measure the voltage. Because why means, if I'm giving the supply to the field, what will happen? Flux will be produced, as current will be induced. So here I cannot measure the, you can measure, but field, it holds the current only. While coming to the armature, only the interaction of two fluxes occur, the EMF will be induced. The EMF I used to say is a voltage also. So I can measure the voltage with respect to armature. Okay, so field, I can measure the current. Normally the field current will be very less, so I can took the 0 to 2 amps. It's enough. Maximum we can run, it is 1.2 or 1.3 only. The field resistance always should be very less. Please note it down also. Field resistance will be very less. The current, if resistance is less, current will be very less also. So it will be at 0 to 2 amps. I have connected with the, if it is, I have repeating once again, if I'm connecting series only, the field current can be measured, because if I connect a series only, the current will be same. You can measure the field current. So I should connect the ammeter with respect to field. That's why I have connected series with the ammeter. The same way for this parallelly connected, because the voltage will be same in the parallel, so that's why I connected in the parallel. Yes, again I have to measure, I have to start the armature resistance will be very high, because we know that the voltage equation is equal to EB plus IA RA. While starting, please note it down, while starting there is no back EMF, it will be 0. So V is directly proportional to IA into RA. So my V is directly, IA will be V by RA. So the starting current I can control by adding a armature resistance. You can add the resistance to the armature, you can control the starting current. So I can add more number of resistance with respect to armature. If I'm adding a more number of resistance, what will happen? My starting current will be very less. That's why I have connected the more number of resistance. This is a maximum resistance. So I have connected the more number of resistance. So what will happen? My armature current, my starting current will be less. Have you all agree my point?
Yes,
Be able
ma'am.
to follow.
And another one, the LFA also it holds some resistance only. It has the series connection of resistor. It all be connected together with respect to armature only. While teaching a 3-point and 4-point starter, I will tell what is there in the starter. If you open the starter, there again we have like a series connection of resistance only, because if I'm adding the resistance only, I can control the current, starting current, because I is directly proportional to V by RA. So I can add more number of resistance. I can control the starting current and armature current. So if you open the starter part also, it has the combination of the resistance only. So that's why I have already told, not to reduce the starting current, you have to add the resistance with respect to armature. So it will be connected together with respect to armature. If I'm adding all the resistance to the armature, the starting current will be very less. So again, if you open that, you can see the what is there in the starters. Nothing but it's a combination of the resistor only. I think all of you little bit clear about the starting resistance and all. Yes.
We'll move to the virtual.
Yes. Next. Sir, once again. So is it clear why am I connecting with the maximum? Why I am connecting with minimum? Is it clear? Is it clear? Is it clear or not? This is the connection wise. The next one, I'm going to the concept. If I'm going to talk about how I'm going to control, then you can move to the virtual lab slightly. Is it clear or not? Yes, clear? I think yes. So I'm moving to the speed. I'm going to control the speed of the decision motor. I can control by varying the field rheostat as well as my armature rheostat. If I'm increasing the field rheostat, what will happen? My speed will be increasing. If I'm increasing the armature rheostat, my speed will be decreasing. Yes?
Okay.
That is another way. Then, if I'm increasing the field rheostat, what will happen? Again, while starting a shunt motor, what should I do? What is the first step you have to do while starting a DC shunt motor?
Load.
Yes. Yes.
Starting with the load.
Yeah,
Starting with the load. That is series motor, guys.
the series motor. I'm talking about the shunt motor. I have told while starting a shunt motor, you have to do the first thing. What is that? Whether it's a constant speed motor? Shunt motor is another name is constant speed motor. Every time you have to run while starting a
1500.
Yes, you have to set the 1500 RPM rated speed with the help of the field rheostat. After that only you have to do the experiment. So if I'm going to turn on, and then you have to turn on the starter. After the first step, yes sir?
We'll move on to the lab now.
Sir, once again. Okay. What will happen? If I'm varying the field rheostat, then you can set the rated speed. So after that, I'm going to control the speed with the help of the both field rheostat and then armature. The method is, first one is armature voltage control, is the field resistance control. The first method is armature resistance control and then field current control. Armature voltage and then field current. It is called field current control. This is called armature voltage control. So what will happen? If I'm increasing the armature voltage, what will happen? My shunt motor speed will be started to decreasing. So the voltage will be increasing, speed will be started to decreasing. The same way, if I'm increasing the field rheostat, field current, what will happen? If I'm increasing, what will happen? it started to decreasing. This is the concept. Sir will teach you again in the virtual lab. So, just you have to follow these two concepts. So, sir, you have to move to the virtual lab.
Yes, ma'am. Yes, ma'am. Guys, you pin to my screen. Okay. Pin to my screen. Guys, are you able to follow me? The screen is visible or not?
Visible, sir.
Okay.
Yes, sir. Visible, sir.
Just in Google Tab, just you type it as VI Lab. Okay. So in the VI Lab, we are having this point. It will open as virtual labs. Clear? We're able to follow. Guys, we're able to follow.
Yes, sir.
Okay. So after clicking to this vilab.co.in, I have already posted you in the chat box. So it will open you the virtual labs website. Clear? So in this virtual lab website, we are having many labs. So in this, we'll move on to the electrical machines lab new, that is IIT Roorkee. Clear? So by clicking to IIT Roorkee for starting VI lab, after clicking the VI lab, you are opening this window. In this window, you want to select there are many labs in it. You want to select electrical machines lab new. So in that IIT Roorkee, it is conducted by IIT Roorkee. You want to click on it. Okay. So after click on it, you are having the electrical. This will open. There is electrical engineering, electrical machines simulation. So in this, we are having so list of experiments, introduction, objective, list of experiments. So just you want to click out the list of experiments. So in the list of experiments, you are having the speed control of DC motor, the field resistance control method. Just click on to this. No, you want to select load test on.
No, sir. Speed control of DC motor by field resistance control only, sir.
Field resistance control method. Yes, ma'am. Clear? You are able to follow it.
Yes, sir. Okay. So in this, we are having aim, that is to study the speed control of DC motor by field resistance control method. We want to plot the graph between the armature current and motor speed by varying the field resistance. Clear? Theory part ma'am will explain already. So directly move on to the simulation page. That is simulation. You want to click out the simulation. If it's simulation, then click here to go to the simulation page. You want to click on over there. So clicking it, one window will open. So like this. Clear? So window will open. So this is the, from here we want to going to connect the things. That is the speed control of DC shunt motor. So this is how the things are looking like. Clear? So this is the on point, that is a supply, DC supply. It is connected with a switch, that is A and B, and this is P, Q and R. It is nothing but it is a 3-point starter. And this, as ma'am told, if it is a DC voltmeter, it must having the plus and minus symbol. So it is the how the voltmeter look like. So imagine it. it is how the voltmeter resembles also. And then the next one is the ammeter. This is how the ammeter look like. If it is voltmeter, V. It is ammeter, it is A. It is denoted by A. And then this is the field rheostat. This is how the rheostat look like. Assume that this is the rheostat points, that is has a position, okay, but it is at the maximum position, okay. We can move here and there, or else if the incoming current, when we connect it to the incoming current at this point, it is telling it is as a minimum position. Whether it is in the outcoming point, out point, it is outwards, it is called as a maximum position. Clear? So here there are two resistance. One is field resistance, and then next one is the armature resistance. And it is connected to the motor. The motor has 4 points, and it is nothing but it is a front view of motor. So these are the things. Here at the your right side, it is having that instructions. So instruction. So we want to nothing. We want to connect the things. What it is right over there. It is nothing but we want to connect the things. That is, it is denoted by a letters. That is A, B, P, Q, R, I, Z, L, M, and then C, D, K, Y, G, H, F, and E. Like that, it is the points are connect. So by just seeing the instruction, you are going to connect it. Okay, clear? You are able to follow. You are following.
It's nothing but I have drawn in the board.
It's nothing but
field rheostat and then armature rheostat. There CD is field winding, a KY is the armature winding. There I can write it as F1, F2. Here the terms only different, C and D and K and Y.
So it is, you just relate with the diagram what we ma'am draws in the board. Okay. So first is the supply, that is plus minus, and next one is the LFA, and then it is connected to the F is connected with the field rheostat, and A is connected with the armature rheostat, and then it has a voltmeter, that is parallelly, and then armature, in the armature it is connected to the field resistance. Like that, the same thing is connected to, motor is connected to A1 and A2. That just relate with that. Okay, what the ma'am drawing. So now we are going to, ma'am, shall I connect it, ma'am?
Yes, sir. Yes, sir.
So guys, please follow it. The instruction, that is A to K, A to Y, A to J, B to P, E to M, F to D, G to R, and M to G to R, H to I, and then I to C, C to
H,
C to H, Q to L. Just make it in any note of that, because if you remove the crusher, it will gone on. Okay, so just I following the instruction that is given in, I note it down, and then I'm going to connect it. Okay, so first connection, want to just click on the mouse left side, and then you want to click from A to where is K? It is K. Clear? That's the first connection will over. Next, from the A, same A point, it is connected to a Y. Second connection is over. Next, from same A point, you are connected to J. Where is J? It's voltmeter, minus point is a J. Clear? And then next is from B, that is plus, from B to P. Where is P? Where is P? It is this starter first point. So just relate it, same the things. And just next one is E. What is E? E is the rheostat 1 point. From E to M. Where is M? Here, E to M. Next is F to D. What is F? The FD is in the motor point. Clear? And then the G to R. G2 on. Okay, and then
Yes, sir.
H2I. Where's H2I? Clear? And then I2C. And then C2H. Where is C? Here C. Where is H? C2H. And then Q2L. Where is Q? And then L. Okay. So this is the instruction that they are given here. So I assume that the connection are correct. Then I will make on the check connection. Okay. So it is pop up a window that correct connections are proceed to take the reading. Okay. For example, I have missed other any miss point. Okay. For example, I am connected this -2 plus. So first we take the reading and then I will explain you what happen if it is misconnection. Okay, clear? So by checking it, it is correctly telling that correct connections proceed to take reading, and I want to select the OK button. So to take the reading, first thing what we want to do, that is the thing is we want to on the supply. After on the supply, then only you are able to take the reading. Right or wrong? Hello, guys.
Yes, sir.
So I'm going to on the things. If it is on, it will turn on to the green color, and then the starter is denoting that the supply is in on condition. Clear? Okay. Oh, the instruction that is telling that show incorrect correction. Check the connection by clicking check button. If it show alert that incorrect correction, then press reset button to make connection again. If shows alert correct connection, then turn on the MCB. Then set the voltmeter first with the help of the second slider. Now move the first slider to get corresponding values of ohmmeter and speed meter. Press the add to table button to insert the value in the table. So these are the things we want to going to do it here. So the slider, they are denoting that it is the armature and the field resistance. So first we are going to increase the start the motor. After starting the motor,
So I have to click the armature resistance.
Armature resistance, yes. We are going to check the armature resistance, then increasing the armature resistance and set it to some value. Okay, saying that the voltmeter is move on to the position, that is move on to the some voltage is induced in it. See here, clear from 0 to some voltage. In voltage, it is denoted as 220 voltage. So I'm slightly increasing it to the next 220 voltage. Yes, ma'am. 220 voltage. So this is the set point of the armature resistance. Now I'm going to take the reading by varying the field rheostat. So by just increasing the field rheostat, what will be happen? So now motor is in, we are increasing the armature resistance. Then the second step is we want to increase the field resistance. The field resistance is, if we are increasing the field resistance, the motor is going to run. Clear? So set the field resistance to the first point. What will happen? The motor is running at the speed of 2500 RPM. Okay, there is some voltage, sorry, there is some current induced in it. What is the current value is 0.18. Okay. For example, in voltage, 220 voltage, what is the current value? 0.18. What is the speed they are having? 2500. And the motor is running at very high speed. Clear? So just by here you are having that the observation table and then the graph. So before going there, want to add this reading to add the table. Add to the table. So by clicking this add to the table, the first value is noted down, that is 0.1 current is run at the 2500 RPM. So next, by repeating the same procedure, next I'm going to increase the value, that is field rheostat, to the next point. Clear? That is 0.2 ampere. The speed is decreases to how many speed decreases? 2340 RPM. Then I want in graphically in virtually it is telling that the motor speed will decreases from first to second. It is noted down, the speed will decreases. Clear? So now I added this to the add to table. Clear? Okay, it's added. See here, that is next reading is added in the table, that is 0.2. The RPM is 2340 RPM. Next again, I am again increasing the field rheostat to 0.3 ampere. Here it is noted that 0.3, and then the speed is decreases to 2100. Same wise, the motor speed also decreases. Here again I added this to the my add to table. Here, and I ensure that the observation table is added or not. And the same thing, I'm going to increase the field rheostat. That is step by step. So next I increase it to increase the value to 0.4. Now the speed of how the speed is 1930. The speed is decreases. Clear? Okay. And I want to add to the table, add the reading to the table. Same. Then I'm going to increase the field rheostat by 0.5. It is denoted by 0.5. The speed is 1700. And then I add it to the add to the table. And then again, I'm increasing the field rheostat by 0.6. Speed is again decreases. It is 1575. And again, I add to the table. And really, we can take a set of 10 readings, I think so. That is next is 0.7. Same thing. The speed is decreases 2480. Add to the table. And again, it's 0.8. Speed is further decreases 1400. And I added to this table. And again, 0.9 amps. Its speed is further decreases. I have added to the table. So like that, from that here increases that increasing the current, that is field resistance, field current, the speed will decreases. Just by clicking the plot graph, we are getting the values. Okay, from 2500 to 1270. Clear? Clear?
Sir,
For having any doubt? For having any doubt?
Sir, 1 second, sir. Nothing else. If you are find out in the field resistance method, you have to keep armature resistance is constant. If you are going to find out the armature resistance control, you have to keep field resistance is constant.
Field resistance is constant. Okay.
So if I'm keeping armature resistance is constant, you can vary the field resistance. You can control the speed of the motor. So if the current is increasing, what will happen? Speed will be decreasing. The same way we are going to do the armature resistance also. So if I'm going to find out the armature resistance control, you have to keep field resistance is constant. You have to vary the armature resistance. So you have to note it down the voltage and then speed. Here the field, you can note it on the current and speed. In armature, you can note it in terms of voltage and speed, nothing else.
Clear? So in the
Yeah.
lab session, in our lab session, we will discuss these things. Okay. Just in virtual lab, you can understand the concept what we are doing in the lab. Clear? If you are having any doubt, please ask us. Having any doubt regarding the
Any doubt,
regarding
ma?
this experiment, speed control of shunt motor?
We have completed only the field resistance control only.
Yeah.
We
Yes,
didn't
ma'am.
do the
Armature.
armature resistance.
So by
We
next
have
class,
to
we will
do
do
the
the
next class,
armature.
we will do it.
So just
Any doubt
after
is-
finishing this, we are having the option as print. So just you want to print it down, and then select it as landscape. So just you make a one print and make a as a PDF, and it's send and submit in the our Google Classroom. Okay, clear?
Yes, sir. Pudunga.
You're having any doubt? Please ask us. Able to
You have
follow
to
it?
do in your mobile lab. You have to take reading, you have to take printout, and then you have to submit in the Google Classroom. Is it clear?
So after finishing it, we will award you the marks after by submitting this. Okay, ensure that you are in the what is that in PDF file you named as your roll number and then name and submit to the Google Classroom. Clear?
And then you have to write how it will be works, and then you have to write the procedure also. Then only you can understand the. Yes.
What is the concept behind it? Okay,
And then only we can award the marks.
for example, if
Because
any connection mismatching connection, if any connections we have mismatch, it means if you select these things, what is this point? Select the point, you will get what are the wrong connection will be gone off. Okay. இப்போ ஏதாவது ஒரு தப்பு பண்றோம்னு வச்சுக்கோங்களேன், தப்பா கனெக்ட் பண்ணிக்கிறோம் அப்படின்னா அந்த பாயிண்ட்ல கிளிக் பண்ணாவே அது எதோ தப்பா கனெக்ட் பண்ணிக்கிறோமோ அது போயிடும். ஓகேவா? கிளியர்?
yes, you have to submit.
இங்க பாருங்க, இப்போ ஃபார் எக்ஸாம்பிள் நான் வந்து என்ன பண்றேன் அப்படின்னா ஏவையும் கனெக்டட் ஏபி and then AQ and then AR and then A thing and then BC. So this is all wrong connection. So if you are going to connect just by clicking the A, wrong connection will go on. Okay. For example, by connecting B, wrong connection will go on. For example, I connect it as B to P. So it is so what are all the wrong connection we have given that will be gone off. Okay, by selecting this we can check. Otherwise அவங்க என்ன வரணும் அப்படின்னா the connection is correct அப்படின்னு வரும். Then only you will want to proceed it back. Clear? என்ன பண்றோம்? VA Labs submit போறோம். VLabs.co.in குள்ள போறோம். After we are going to VLab.co.in, want to select the electrical machines lab new, that is IIT UK. By selecting this, you will get a list of experiments. After list of experiments, you are going to the speed control of DC motor. So by clicking to the speed control of DC motor, you are having the things. That is same theory, pretest procedure and all. By selecting the simulation, you are having one pop-up window. So just by clicking the simulation, go to the simulation page. You are having this window will open. After going to this window, just select the instruction point. After checking the instruction, just you are going to connect the dots given here. After connecting the dots, we want to check it once by selecting the checkpoint. It is say that the connection are correct. If it is incorrect, it will pop up the window. The connection is incorrect. Then take the reading. Clear? For having any doubt, revert us back. Clear? Clear, guys?
Yes, sir.
Okay. Okay, ma'am. Shall we wind up it, ma'am?
Yes, sir. Yes, sir.
Thank you, guys. Thank you.
Thank you, sir.
If you have any doubt, please ask me in message
Sir,
or call.
how to open the wheel app? So I will post it in the group
So
also. Just
stop the recording, sir.
this one.